In our study of trigonometry, there are two special triangles that we are going to use over and over to solve problems. So we want to highlight those today. The first one that we're going to work with is our 45 degree, 45 degree, 90 degree right triangle. Our second one is our 30 degree, 60 degree, 90 degree right triangle. We call these our special triangles because the side lengths of these triangles behave in predictable, consistent ways, and that lets us use what we know about these triangles to solve for missing side lengths. Let's start with our 45, 45, 90 triangle. We have a rule in geometry that tells us that if the base angles of a triangle are the same, the side lengths, or those legs, are as well. So we're going to label them each with a 1. We also have a rule from geometry that tells us that if we have a right triangle, we can use the Pythagorean Theorem, which says that a squared plus b squared is equal to c squared. And that helps us find missing side lengths. So since we've labeled sides a and b with 1s, now we have 1 squared plus 1 squared is equal to c squared. 1 squared is 1 plus 1. So we end up with 2 equals c squared. But we don't want to know about c squared, we want to know what c is, what side c is. So if I take the square root of both sides, we find out that c is the square root of 2. So what this tells us is that in our special 45, 45, 90 triangle, the legs will always be 1s and the hypotenuse will be the square root of 2. Now let's take a look at our 30, 60, 90 degree right triangle. Let's first take a look at where we build this triangle from. So let's start with an equilateral triangle. If you remember from geometry, that is a triangle where all 3 sides are the same length, and that also creates 3 angles that are the same size, 60 degrees each. Now let's take this triangle and cut it into 2 equal pieces. Okay. This line here will be perpendicular to the base, making a 90 degree angle. Since we cut it in half exactly, this up here, this smaller angle, is now half of 60, or 30. So here's how we've created our 30, 60, 90 degree right triangle. Let's take a look at what happened to the side lengths when we created those 2 smaller triangles from our bigger one. Let's take a look at the smaller triangle we've created here. I'm going to redraw that. So here's our 90 degree angle, our 30 degree angle, and our 60 degree angle. We saw over here that the 90 degree angle here, created a side that was twice as large as the side across from the 30 degree angle. So in order to help ourselves envision that a little bit better and avoid using some fractions, let's call the side across from the 30 degree angle a 1. Now we see that the side across from the 90 degree angle needs to be twice as large as that, so we'll call that a 2. All we need to do now is find what this third side will be. Again, since we're using a right triangle, the Pythagorean theorem applies. So we can say a squared plus b squared is equal to c squared. The important thing to remember is the side across from the 90 degree angle has to be the c. So we have 2 squared here, 1 squared here, and we're looking for that second leg of the triangle. 1 squared gives us 1 plus b squared is equal to 4. We want to get the b alone, so I'm going to subtract the 1 over. So that gives me b squared is equal to 3. Again, we want to know about b, not b squared. So I'm going to take the square root of both sides, and that gives me that b is equal to the square root of 3. So in every 30, 60, 90 degree triangle that we have, the side across from the 30 degree angle will always be the smallest one. The one across from the 90 degree angle will always be double whatever that smallest one was. And the side across from the 60 degree angle will always be the square root of 3 times whatever the smallest side was. So let's just review what we've just learned about the side lengths of our special right triangles. In a 45, 45, 90 triangle, the legs are the same size, and the hypotenuse is the square root of 2 times whatever those legs happen to be. In a 30, 60, 90 right triangle, the shortest side is the side across from the 30-degree angle. The hypotenuse is double whatever that is, and the side across from 60 degrees is the square root of 3 times that shortest side. So let's use that knowledge to do a few examples. In this example, we know we have a 45, 45, 90 triangle from our labels. We're also given one of the legs, and we're asked to find the hypotenuse. So if we remember, we weren't asked to find this leg, but we know that in 45, 45, 90 triangles, those legs are the same, so we know it's 7. Now, we also know that the hypotenuse is the square root of 2 times the length of our leg. So without having to do any extra calculations, we know that this side is 7, because that's the length of our leg, times the square root of 2. Now we have a problem where we're dealing with a 30, 60, 90 triangle. And if it helps you, we're only shown in the picture the 60-degree and the 90-degree. So if it helps, you can certainly write in that 30-degree angle to keep track of everything. So let's remember what we know about 30, 60, 90 triangles. We have the side across from the 30-degree angle. And that's good, because the other two sides depend on that one. We know then that the hypotenuse, remember that's the side across from the 90-degree angle, has to be double whatever that is. So we know that this side is 8. Then we know that the side across from 60 degrees has to be the square root of 3 times that short side. So we know that this side is 4 times the square root of 3. And if you were doing a quiz or a test and wanted to make sure that was right, remember that you can check that by using the Pythagorean Theorem. In our third example, we again have a 45, 45, 90 triangle, but this time, instead of knowing one of the leg lengths, we know the length of the hypotenuse. So let's see how we can still use that to figure out what we don't know. If we remember, we know that the hypotenuse of a 45, 45 degree 90 triangle is always the square root of 2 times the length of the leg. So we know that the length of the leg, which is x, times the square root of 2 needs to equal 8. Now all we need to do is solve for x. So since x is connected to the square root of 2 with multiplication, we will undo that by dividing both sides by the square root of 2. That leaves x alone on one side, which is what we want. And now we have 8 divided by the square root of 2. The only thing we have to do now is we need to rationalize that, because remember, we're never allowed to leave a square root in the denominator of a fraction. So to fix that, we multiply both the top and bottom by the square root of 2. So now on the top, we have 8 square roots of 2 over the square root of 2 times the square root of 2 just gives us nice old plain 2. Now the last step we have to do is just reduce if we can. In this case we can. 2 goes into 8 4 times. So we get 4 times the square root of 2. So that tells me that my missing side length is 4 times the square root of 2. These two special triangles are really important, our 45, 45, 90 and our 30, 60, 90. So you will want to memorize the ratio of those side lengths to help you solve all sorts of problems that we'll do this semester.